So our problem of the day addresses the different ways that molecules can represent bonding in a Lewis structure. We've been learning this week that scientists have come up with an admittedly arbitrary but still useful separation of bond types into ionic, polar covalent, and non-polar covalent. And we've gotten pretty familiar with ionic, metal, non-metal, tends to form a crystalline structure, high boiling melting points, fairly conductive in aqueous solutions, and that's when we have a strong electronegativity difference between a more electronegative and electropositive of 1.8 or more. Table salt is a classic example. Polar covalent, where there's still a significant polarity difference between one atom and another, somewhere between 0.5 and 1.8, but it's more of a sharing of an electron orbital pair rather than ionization, where an electron is being given away by the more positive element and a negative by the negative element. But even though we do have a sharing, and we denote those with these bond lines, we still put these dipole symbols to indicate that there is sort of a partial imbalance between a more negative atom and a more positive atom, using water as an example. A lot of organic acids and carbohydrates are to some degree polar and will sometimes carry very slight ability to conduct a charge. The boiling points and melting points for these substances tend to be significantly lower than the ionic compounds that we denote in Lewis structures with charge symbols and the non-metal getting the octet. Non-polar covalent compounds, on the other hand, imply almost near sharing of electrons because the electronegativity difference is very low, less than 0.5. Methane is a good example here, and we don't use dipole symbols, we just use dots and dashes. Fats, oils, waxes are good examples of non-polar covalent compound. So this week we're going to take 3 compounds that I want you to A, draw the Lewis structure for properly with whatever symbols are appropriate, and B, some way of charting out how you justify the different types of Lewis structures based on analyzing the relative electronegativity differences between the atoms that are involved. So let's take a look at the 3 that we have to work with this week. So here are our 3 compounds: carbon tetrabromide, aluminum fluoride, and silicon dioxide. So for each one, draw the Lewis structure and with the appropriate symbols, and then alongside it, analyze the electronegativity relationships between the atoms in the bond that justify what types of symbols that you use in your Lewis structure. Like to have these by 10 p.m. and I will show these solutions in a video tomorrow. Good luck.